Welcome to Illinois Groundwork. This is an online resource of research and tools that can help to optimize the design and planning of green stormwater infrastructure in communities and cities. And I'm pleased to introduce you to Dr. Dave Grimley, who's going to talk about Amoozemeters. What are Amoozemeters and how are they used to measure rainwater infiltration in different soil types that are saturated? And this is a tool that we use in our own research in the Calumet region of Cook County in Illinois. And this is a very valuable research method for doing in situ, field-based infiltration studies on the very soils that you'll be using in your own design, planning, and modeling process. Here's Dave.
Thank you, Mary Pat. In this video, we're going to look at Amoozemeters, what they are, how we use them in the field, and how we can calculate the saturated hydraulic conductivity values from them. Amoozemeters are compact constant head permeameters, which means they can collect data of in situ saturated hydraulic conductivity in the unsaturated zone above the water table. But what we're going to do is we kind of add water to saturate it during the experiment to create the constant head or constant water pressure. And so what these do is they measure the infiltration rate within an auger hole that we drill in by hand at a particular depth, usually within 2 meters of the ground surface, although you can go a little deeper. The method is named after Dr. Amoozagar, and I'll show some links to his papers and website later. It's also used by the USDA NRCS in their research and for other purposes. So to prepare your site before you take the field measurements, you have to first pick a representative site that's going to be useful for the data that you want to collect for a particular map unit or for a particular type of field area that you're studying. Next, you want to take a hand auger or soil probe at the site to evaluate the soil horizons and characteristics and sample it. This will allow you to figure out where do you actually want to do the Amoozemeter measurement, because you do it at a particular depth in the soil, at a depth of interest. And so we picked usually the middle of the B horizon or the upper C horizon, but you can pick whatever layer you're interested in. This is a list of just how the Amoozemeter is built and what's contained within it. So for the field method, just kind of a brief version of that, you first have to hand auger a new hole to the depth that you want to choose for your deepest measurement. And you can do multiple measurements within that hole, actually. And the diameter of the hole is typically 6 centimeters, but other diameters are fine as long as you account for that in the equation later on. And you keep a constant hydraulic head in the auger hole during the experiment. And in order to do that, you have to monitor the infiltration rate until a steady state flow is attained. And once you attain that, then you start the water drop and you measure that over time through the Amoozemeter and you mark it on tape. So for a little more extensive video of that field procedure, I'm providing a link here to a YouTube video by Dr. Amoozagar himself. And this is also his original paper where he documented the method and the equations that you use. And here are some of the calculations we did in the field using these equations. So you have to consider the hole depth, the hole diameter, the water level in the hole, and the rate of water level drop, which is what you basically measure in the field. You can see here is the tape that they took from the field on the Amoozemeter, and they put it onto the paper. And every 2 minutes, in this case, they made a mark on the paper. And they did that over over a half hour, so they marked it several times. And here's an example of where you use those markings to measure the water drop, and then you calculate your final saturated hydraulic conductivity based on an average of all those markings and water level drops at that particular depth at that particular site. Okay. So the advantage of the method is that you can measure in situ hydraulic conductivity, which encompasses, biological pores and fracturing and other things that you wouldn't get from a laboratory sample. It's also more portable and versatile than other field methods of measuring this. And for example, you can store water in the unit during transport. You can fit several in your vehicle and run several at once. And it's constructed of durable materials that can withstand field use. The limitations are that it won't work at or below the water table or in rocky soil where you can't hand auger. And you need large quantities of water sometimes in very permeable soils. So lastly, I have some data here that I want to show you from our Southern Cook County study, where we had 5 sites in the Midlothian area and 6 in the Calumet City area. You can see from the larger dots and the brighter colors that the KSAT values or hydraulic conductivity were much higher in the sandy beach ridges of Cal City versus the lake plain areas of Midlothian, where infiltration rates were much lower. So now we have a quantitative data that we can use for our modeling. And if I zoom into the Cal City area, you can see, 5 of the sites up on the beach ridge have pretty high rates in the 6 to 37 centimeters per hour rate of infiltration. But the one site here in the lake plain is a much, much slower infiltration rate. So that gives you an example of a real world situation and actual numbers that you can get from this method. And thanks for your interest and listening